Good morning, dear students. Hope you are doing well. Yesterday, in the previous session, we have seen geometry correction, and also we have discussed a little bit about radiometric correction, which are part of image pre-processing. And today, we are going to discuss the next topic, image enhancement. Before going to discuss about that image enhancement, see here, I would like to discuss about the previous topic what we discussed, just a little bit, just to connect to the topic what we are going to discuss right now. Dear students, hope you all know that we are in second unit. The first unit, that means when you have a look over the classes went on, I'm believing that you understood how the images of the target scanned by the sensors and in what mode they send to the processing station. In what mode in the sense type in an electronic language. They used to send the images into the processing stations. Whatever the processing taking place in the stations and processing station that we discuss as part of our curriculum from unit 2. There we have discussed the image processing will be in two categories. One is visual image interpretation technique. There we have seen different parameters based on what the analyst can interpret the images that lies the spatial data. After that, we entered into the process by name digital image processing. In the digital image processing, why it is needed? Why processing is needed? Because to interpret the data, to interpret the characteristics of image, the data has to be processed in such a way we can get the image resolution in a more understandable manner through which we can retrieve the information of the object. That's why the digital image processing has been divided into two categories based on the topic what we discussed. We can think on the other follow topic. The first one is digital or else image pre-processing. If pre-processing is there, obviously followed step is processing. In the image processing, pre-processing, what we are doing, we are making the image to fit or as to be fit in the next category. You yourself are making fit to promote to the next year, or else you yourself are molding yourself to get a seat or as to get an admission where you want to see yourself after your BTech. The same way, the images are pre-processing. For what? For making them to be fit for processing. In the pre-processing we have seen, or as the pre-processing has been divided into two categories again. All the radiometric issues, yes, all the measurements, all the energy related issues, energy in the sense electromagnetic radiation measurement issues, are flaws that are occurred or as that may occur with respect to radiation. we discuss in radiometric correction, where we have seen removal of missed scan line, removal of random noise, sun angle and topographic correction, and atmospheric correction. After that, we entered the next category of image pre-processing, which is part of image processing, that is geometric correction. Here, the flaws that are associated, the errors that are associated with respect to shape, scale, and any such type of issues will be resolved in this geometric correction. And what are the base reasons for this geometric correction we have seen? Instrument error, platform instability, at the time as the earth is keep on rotating or as due to the rotation of earth at the time of image acquisition, and we have seen curvature nature of the earth. These four are the basic reasons why the images may have the flaws in association with respect to shapes, curves, and scales or as projections, so on. Here we are discussing, we are just correcting those errors by dividing them into two categories: systematic corrections. There we have seen two categories. One is scan skew and non-mirror velocity variations. The scan skew, because of the forward motion of spacecraft, the scanned the scan line is not matched to the exact ground track. Because of the difference, those flaws may occur. In the non-mirror velocity variations, before we are going to know, to discuss, to think on it, let's to know about it, you must know the mirrors are not at a constant rate from starting to ending while scanning. If I know the mirror velocity, if anything wrong, I can easily estimate how the scan was taken at the time of acquisition of the image. And the coming to non-systematic errors. Before we are going to discuss about non-systematic errors, you must know what is GCP, Global Controlling Point. Global Controlling Point are nothing but to give the seen evidence. Whereas these are the points based on which we can correct the data. Normally, global controlling points will be considered for better and good interpretation where the image characteristics will be find out with good accuracy and reality. Normally, the permanent structures like road instructions, runways of airport, edges of dams and buildings, agriculture fields, etc. will be considered as GCPs. And once these GCPs comes under non-systematic errors, where the images are correcting with respect to two categories. One is image to ground geocorrection. The image is correcting based on the GCP what we have, where the GCP is at study location. Based on the global controlling points, that means when you are entering a college, a gate with a good arch is at the entrance, not at the back. So GCP is gate with arch. In your image, the gate is at a front side within a big arch, both are matching, so the image is good. If it is not matched with the respective selected GCPs, somewhere the process went wrong. So in this way, we can correct the images. Coming to image, the image of the spatial data, or else the image what we got, will be compared with the image of the same area which has taken at different timings. We'll compare to each other to set right if any flaws are there. That is called as image to image geocorrection. Miscellaneous pre-processing you have seen. Subsetting. Subsetting in the sense, normally remote sensing images covers or else holds large files. If the large files are storing, it takes that means the data consumption is more and the storage space also more. That's why just cutting or else breaking off such large files into the one or more files what we want is called as RS based on the requirement called as subsetting. Spectral subsetting, as you know, the image will be recorded by different bands of electromagnetic spectrum. The spectrum whatever I want to isolate from the different bands, or else taking the data from the required band by removing the non-required bands known as spectral subsetting, mosaicing. This is just vice versa to the first method. Sometimes the study location will be available in different images. The adding of all the images and making it as one large file to retrieve the information of study location is called as mosaic. Now is image enhancement. You yourself are enhancing with respect to your education. After BTech, you want to enhance your education, your qualification, then you may go to a master's. After first mid marks, you are enhancing your marks with much hard work. In the same way, the image is enhancing based on the requirement of you. If I want to highlight one particular part of your face, you can enhance. If you want to reduce what you want to reduce, that we'll discuss in the next classes. Here, enhancement. While we are doing enhancement, while we are adopting the enhancement procedure, there are two types of operations. Whatever we want to do to the images, we have to do with respect to digital numbers. Why? Because the image in remote sensing, as you all know and we discussed, the image in remote sensing speaks about the digital numbers, which are in a range from 0 to 255. If you want to enhance, there is no way you can increase the value of pixel or based on the need. You may be decrease. You are enhancing. Normally, if you want to enhance the quality of image, there will be a saturated stage. If you want to enhance more than that saturated stage, there also you won't get the information what you want. That means for everything there is a saturated stage. You know, you are in final year, you must work hard to settle well. At the same time, you have to know that you must take care of your health also. If you are allocating long, lengthy study hours, and if you are skipping nights, skipping sleep to crack in rank, getting a rank is the next issue, but your health is going to be a primary issue. What I'm speaking is, When you are enhancing the quality, that means when you are changing the brightness value, up to there is a mark. If you want to try more than that mark, even though the image may not be get clear, simple with your remote, you want to enhance the image quality by sitting on a sofa set up to certain mark, certain point, the image is clear. If you want to increase, slowly the image may lose its appearance. That means the enhancement is restricted. Enhancement in the sense not only with the changing values. Say here, whatever you are going to do, there are two types of functions you can operate. One is point operations, the other one is local operations. Point operations, changing of values, pixel values, without concerning neighbor, without concerning other sets. Whereas local operations, changing of values in context of neighboring pixels. In point operations, we discuss, and in the previous semester we have seen this nice subject, environmental engineering 1, where we more focused on environment. The waste that you are collected from your home, if you are dumping without concerning of neighboring people, just an area where other people will influence, or else simply you're dumping waste without any concern of neighbors, is point operation. And dumping waste by concerning other people inconvenience as per the protocols you are dumping, that is local operation. I can go for only here, only in this context. We are changing the value without concerning neighboring values. That is point operation. You are changing the value with concern to neighboring values is local operation. You are using water more and more than the requirements without any concern of future generation. The entire people has to be, or else the upcoming generation will suffer. That means in the natural perspective, natural resource perspective, we can define these two like this. When we are consuming natural resources, you must always think on the future generation, which we can conclude it as local operation. See here, coming to our topic. See why we discuss natural resource in a sense. That is also our topic. And of course, I think some other continuation part also now going on. E1 is over. Now the continuation part is going on. Whatever is related to surroundings and environment. Coming to our topic, hope you know that point operations and local operations, strong foundation laid, hoping that a strong foundation laid in our minds. Coming to the first topic is image enhancement. This is image enhancement, and in this image enhancement, the first topic is image reduction. See, why here image is reducing? What is the need of reducing? Because the resolution of remote sensing images just not suitable for the resolution of normal computer screens. That means the resolution of remote sensing images are not suitable, are not compatible with the resolution of normal computer screens. In such constraints, for better interpretation, for better resolution, or for better understanding, we must reduce the image in all the aspects. What the reduction, in the sense, what we are reducing? We are reducing the image size with respect to rows and columns. What is digital image? The digital numbers are speaking image that is stored in equal square shaped grid cells located in columns and rows, called as pixel. That means reducing, in the sense, what I am reducing here, just the sizes of as number of rows and columns are reducing. How much I can reduce based on my need? How can you tolerate, and how can you overcome, and how can you maintain the patience when it is crossing its permissible level? Did you understand what I said? How much rows and columns you can reduce? That's up to based on your requirement. That means there is a barrier. For example, in attendance perspective, you have to have some amount of attendance percentage, and you know how to maintain it. And up to that, the point is saturated stage, and you're not supposed to cross that saturated point. If you try to cross, you may get one more chance. That means you may not move forward in your respective class, or else from your respective class, or else in your respective curriculum. What I'm speaking is the image must be reduced. How much? Based on the requirement and need, where you can get the your purpose. That means, for example, 2x reduction. In this 2x reduction, if 1000 columns and 1000 rows are there, that will be reduced into 500 into 500. See here, this is the original image. This is the original image. 2x reduction, in the sense, every second column is reducing and every second row is taking off. That means this is the first 56, this is the third. That means second column is reduced, 2x reduction, because this remote sensing data is not compatible in the normal screens. So I must reduce the data. This is the 2x reduction. You can go further and you can increase the number. See here, 56, 52, 74. That means every second column are removed and every second row also removed. This is called as image reduction. That means 2x reduction. What you should write when you got a question, write a detailed notes on image magnification and reduction. You must write in remote sensing, the satellite images data may not be compatible for normal computer screens. In such cases, the data must be reduced and the data must be reduced as per the requirement where I can perform the operation. You just reduce somehow. There is in a large file where four people are there, including you, and you want to see yourself. You may not cut all three people where you also one in those three people. The other one, what you don't want, that is left. But what your intention? You want to crop the image of you in the four persons of image. That means your objective is you want to crop your photo and you want to cut your pic or is your image from the other associated persons. That is objective. If you are cutting those three members, in those three, if you are also there, there is no meaning. That means you must be there. That is your objective. What is your operation here? The operation must be fulfilled. You are regularly coming to college. Once you are coming to college, you must be in the classroom, which is to be considered. You are coming to college and you are coming to up to the gate and you are not coming to college. There, no use. Here, you are reducing, but how much? The way you can perform the operation, perform the task, what is required. Here, I just shown to you 2x reduction. This is what enough for me in this case. So I just reduce. I just go for 2x reduction. If I go for 2x reduction, this will be like this. When you are writing an exam, whenever you got the question, you must write this original image and reduced image also with this arrow. The next one is image magnification. What is our topic? Image enhancement. Enhancement in the sense, whatever whether I am magnifying or reducing the contrast or else the digital number value, that image must be compatible. The image must be clear with good resolution so that so that I can understand the characteristics of the image, so that I can understand what holds in that image. Next is image magnification. By the name itself, we can easily understand what is magnification. Something is doubling. See, I just mentioned it as a zoom in. If it is zoom in, and obviously what it is, zoom out. You can add one more point here also. This process also called as zoom out, where the number of rows and columns are reducing for making the image to be fit in the computer screens. And the reduction must be done by keeping view of the operation that is going to be performed. If it is the two, for instance, this is the way of reducing the size of images, reducing the images. If we go for 2x reduction. Image magnification, what are the objectives? Simply, I just enhancing the display scale. Display scale in the sense, nothing but resolution here. For enhanced visual interpretation, I just utilizing the display scale where I can get the interpretation, where I can get the data. Understand what are the objectives here? Just enhancing display scale and comparing scale of this image to another image where I can get the good information. This is what about 2x magnification. See here, what are the objectives? Enhancing display scale and matching the display scale of another image of the same location, which gives, which holds good resolution. See here, this is what about 2x magnification. How can I go for, how can I magnify, and what is the amount that I can magnify? That also depends on you, on your need. You want to magnify the issue. You want to magnify the thing what went on. There are certain situations when you are narrating anything to someone, you can magnify the situation or you can reduce the situation based on the requirement. If you have a time, you can go for a good elaborated matter. With respect to time, I am speaking about here. If you're not having time, you can conclude simply within a short span of time. See, with respect to the data, images, in the previous instance, we have seen how to reduce the data. Now here, how to magnify the data. See here, this is the 2x magnification. That means every column and every row will be doubled here. 26, 26, 30, 30, 86, 86. Again 26, 26, 30, 30, 86, 86. Again same 142, 140, 130, 130, 42, 42. 142, 140, 130, 130, 42, 42. Again 65, 65, 210, 210. This angle 210 and 210, 180, 180, 180, 180. That means this is what about 2x magnification, where I can get the information of the image based on my or based on the analyst requirement. We are discussing about image enhancement. Image pre-processing is over. The topic is over. Now we are image enhancement, nothing but processing. In the image magnification, what is the objective to make the image in a more understandable manner for retrieving the information of the study location. The first and foremost thing is image reduction and magnification. We have seen. Hope you understood how to magnify and how to reduce. You must write, when you got a question, you must write what is image magnification, what are the objectives of image magnification, and what to do, and what you need it, what you must because of what we must adapt. Because sometimes the data or else the information, the image must be magnified to locate on one particular task. In an image, as it covered wide area, I want to focus on one particular subpart of the image, I must magnify it, zoom in. Whereas if I want to watch the image as in a whole, I can reduce the size. Hope you understood the difference between zoom out and zoom in. Most of the people used to do with their cell phones after they captured the images. For better visualization, for better understanding, you used to enhance the image. Somehow, if you capture a notice from your notice board where the font size is very minimum, if you feel that you are trying to enhance the image of the circular, what we captured from the notice board. Hope you understood what is image magnification and image reduction. Now is contrast enhancement. Before we are going to discuss contrast enhancement, what is this contrast first of all? Here the range of brightness values present on an image called as contrast. What is the contrast of the image? This contrast is differ to every individual televisions. Every images the contrast is different. The range of brightness, if the minimum is 40 and the maximum is 210, that is the contrast of the image representation. The range of brightness values present on an image called as contrast. What is normal, minimum and maximum? 0 to 255 is the minimum and maximum range. But to this to one particular image, or else the image what you want to study, the range of brightness value is called as contrast. Sometimes there will be a need to enhance that contrast for better understanding. for better interpretation of the image quality. In such cases, we should go for enhancement. Now, what is contrast enhancement? See, it is a process which makes the image features stand out more clearly. It is the process where RS which makes the image features stand out more clearly. How? By making optimal utilization of colors on the display or output device. I can enhance if the device is not having, if the color device is not supporting, even you want to enhance, you can get you won't get it. That means for the enhancement, there is a limitation. What is the limitation? By making optimum utilization of available colors on the display or output device. Now, what is contrast enhancement? It is in a process where RS which makes the image features stand out more clearly by making optimal utilization of available color resources, RS color sources on the display or color device, RS output device. That is what about contrast enhancement. In this contrast enhancement, RLs, contrast manipulations involves changing the range of image values to increase the contrast. In this process, RS, the process involves change of pixel values to increase the contrast. We discussed 3 points under contrast enhancement. One is what is contrast? The range of brightness values of an image is called as contrast. It is in a process which makes the image features to stand out more clearly by making optimal utilization of available color source on display or output devices contrast enhancement. In contrast enhancement, RS, this process involves changing of the values to increase contrast. If I want to increase the contrast, I must increase the value also. As 0 is dull, 255 is high brightness. If I want to increase the contrast, I must increase the digital number also. That's what we are discussing. Contrast manipulation involves changing the range of image values to increase contrast. We're just changing from low to high based on the need and requirement. We can go for any type of change. See, what is the need of this contrast enhancement? The first one is whenever it is required, RL. Second one is when the image is captured with low dynamic range of grayscale. When the image captured low dynamic, somehow if you're trying to capture the image of circular from the notice board, if you are capturing from the distance, the image is not clear. Distance, that is only one of the parameter where you may not capture the image more clearly than you are capturing image just an acceptable distance. You can get good image. What I'm speaking is here to bring out the information which is existed within low dynamic range of gray level image. Gray level image in this is nothing but resolution. See, whenever the images have low dynamic range, the contrast enhancement is one of the technique to enhance the quality of image. What we are discussing? Image enhancement. Next, to understand about this contrast enhancement, one has to know what is histogram. To understand the concept of contrast enhancement, one has to know what is histogram. Histogram is nothing is there. The range of brightness values that holds an image is called as histogram. Means range of brightness values from here to here. This is called as histogram. What is contrast? The range of brightness value present on an image is called as contrast. See here. What is histogram? The range of brightness values that holds an image is called, that is the graphical representation of brightness values that holds an image is called as histogram. Now we understood what is histogram. Sorry, what is contrast enhancement, why, what is the need and what we are doing. And how we can enhance this contrast? Simply, there are two methods. One is linear contrast enhancement and the other one is non-linear contrast enhancement. When I can apply this linear contrast enhancement? When the contrast enhancement linear contrast enhancement expands or else linearly expands the original digital values of spatial image data into new distribution. See here, one word is there. The contrast is expand linearly. The contrast is expand linearly. This is histogram. The contrast is expanding linearly. See here, in this expansion, it utilizes total range of display device resolution. See here, in linear contrast enhancement, linearly expands the original digital values of spatial image data into new distribution. That means the original values of the data is replacing with new distribution values, or else with the values of new distribution. Understand? The linear contrast enhancement linearly expands the original brightness values into the new values of distribution. There are different methods under this linear contrast enhancement. When we discussed about nonlinear contrast enhancement, you can understand more this linear contrast enhancement definition. The histogram is expands linearly where the original digital values of spatial image data into new distribution. The original values are changing into new values of distribution. There are different methods under this category and we are discussing only two here as part of our curriculum and syllabus. We are discussing two in linear contrast enhancement and two under non-linear contrast enhancement. See here, the first one is minimum maximum stretch. The first one is minimum maximum stretch. Else you can call it as minimum and a maximum stretch. The other one is saturation stretch. What is this minimum and a maximum stretch? And what is this saturation stretch? We'll discuss. In next class. Today we have seen under image enhancement, we have seen image reduction and image magnification. And we entered into the topic contrast, why it is needed, what is contrast, what is histogram, what is contrast enhancement, what is the need, and what are the types we discuss. There are two types under contrast enhancement. One is linear contrast enhancement, the other one is non-linear contrast enhancement. Under linear contrast enhancement, the contrast of the image is expanding linearly where the original digital number values are replacing with new values of distribution. While it is expanding, while the contrast is expanding, it utilizes total range of display device resolution. Or else it utilizes total range of resolution of display device of unit. There are different categories under linear. There are different methods under linear contrast enhancement. Among them, we are going to discuss two categories. One is minimum maximum stretch, else minimum and maximum stretch. Other one is saturation stretch. The other name of saturation stretch is percentage stretch. We'll discuss. We'll discuss in next class. Hope you understood about this image enhancement. Under image enhancement, image reduction and image magnification. You must write and you must draw those images with pencil in a good looking or else neat. You must maintain a neat labeled sketch. Labeled sketch and here nothing in there. I mean, what you are going to label there, what is column and what is row and what are the bands. And you must use the pencil more frequently, and you must write down those numbers with pencil, HB, 2 HB pencils. And you must, in the days to come, in coming classes, you are going to encounter different graphs, and all these graphs we are going to discuss in next class. And there also you must use the pencil when you are attempting these questions in examinations. If you have any doubts, please contact me in the domain whatever feel more convenient. Thank you.